Alright, we have been solving systems of equations. We started first by solving them with graphing. We're going to look at another way to solve systems of equations today. This way is called substitution. When we know two things are equal, we can substitute one for the other. So if we know that x is equal to y minus 1, I can substitute instead of x, y minus 1 in my first equation. And then I have an equation with only one variable. Y is the only variable in it. And so we can simply solve this equation for y. So we'll start by distributing 3y minus 3 plus 2y equals 7. Add our like terms. 3y and 2y makes 5y minus 3 equals 7. Add 3 to both sides. 5y is equal to 10, which means that y is equal to 2. Once you've established that, you can substitute that back into one of your equations. It really wouldn't matter which one, but I'm going to choose this one because it's the one that is set up in an easier method. We say that x is equal to y minus 1. If y is 2, 2 minus 1 is 1, which means that x is 1. So I have the ordered pair for the solution, 1, 2. Let's look at another example. Let's look at 4x plus 3y equals 8, and y equals 3x plus 7. Again, knowing what y is equal to, we can substitute 3x plus 7 in place of y in my equation. So 4x plus 3 times 3x plus 7, because that is equal to y, 3y, equals 8. Go ahead and distribute. We only have x in this equation now, so we can solve for x. So 4x, 3 times 3x makes 9x. 3 times 7 is 21. 4x plus 9x is going to be 13x. Go ahead and subtract 21 from each side. And 13x equals negative 13, which means that x is equal to negative 1. If I go back and plug that into either one of my first equations, but again, I'm going to choose this one because this one flat up says that y is equal to 3x plus 7. If x is negative 1, 3 times negative 1 is negative 3 plus 7, which means that x is 4. So my ordered pair for my solution for this equation would be 1, 4. I'll be happy to answer any questions that you've got.